In this problem, we're told a 7 kilogram bowling ball moves at 3 meters per second. How fast must a 2.45 ping pong ball move so that the two balls have the same kinetic energy? So what we're trying to do is solve for these, and we're going to make them have the same kinetic energy, right? So we need to know the velocity v, right? How fast this ping pong ball has to move in order for them to have the same kinetic energy, right? So in order to solve this, you need to know the formula for kinetic energy, right? Which is equal to 1/2 mv squared. So what we're going to want to do, right? Think about this. So if we can calculate the kinetic energy of this ball, right? And we know what that is, we can set it equal to this, and then we can go ahead and solve for v, right? Because their kinetic energies have to be equal, right? So that's exactly what we're going to do. So let's calculate the kinetic energy of this first, right? And we know this is the formula, right? Which is just mass times the velocity squared times 1/2, and we're given all these. So let's just calculate it. So for this, k is going to be equal to 1/2 times the mass, which is 7, right? 1/2 times 7 times v squared, which is just 3 squared. So just plug this in your calculator, 0.5 times 7 times 3 squared, right? So when you do this, you're going to get the kinetic energy, right, is equal to 31.5, and then the units are in joules. So 31.5 joules. And so if we want to have the same kinetic energy, that means the kinetic energy of this has to be equal to 31.5, right? And so the formula for it is 1/2 mv squared, and we want it to be equal to 31.5. Right? And we know the mass of it, right? So we need to find the velocity for it to be equal. So 31.5 equals 1/2, right, times the mass. And so in this problem, given it in grams, so we need it in kilograms because this is in joules, and it wouldn't work if this was in grams. So if you want to convert it, right, so 2.45 grams, there's 1,000 grams for every 1 kg. Meaning if you want to convert it, you just have to divide it by 1,000, right? Because you'll see these cancel. So you just want to do 2.45, and then you're going to divide it by 1,000. So when you do this, you're going to get it equals 0.00245 kg. So this is going to be the mass now. So let's plug it in, 0.00245, and then multiply by v squared, and we're solving for it, right? So what you want to do is you can multiply both sides by 2 to get rid of this. 2 times 31.5, that's just going to be 63. And so now that we got that, right, we can go ahead and divide both sides by 0.00245, right? So 63 equals 0.00245 multiplied by v squared. So divide. So do 63 divided by 0.00245. When you do this, you're going to get a pretty big number, 25,714.28571 equals v squared. Square root both sides to get rid of the square, so we just get v. Okay. And then square root your answer. So square root the answer. And when you do that, you're going to get it equals, or v is going to be equal to 160.3567451. You can round to however you want. This is going to be in meters per second because we use joules and kilograms. So you can round. I'm just going to round to 160.4 meters per second. And so what you have to realize about this problem is that we don't know if the velocity is either positive or negative, right? Because it can be either or, because think about how this works, right? We're squaring the number, and that's just going to get rid of the negative. So really plugging in this v, if it's plus or minus, it's not going to actually make a difference. So you can just specify that it's plus or minus because it's not going to make a difference, right? So 160.4, that's going to be your answer, right? So this was your direct answer. You can round however you want though. But yeah, so this is your answer, and hopefully you found this useful.